So please have a warm welcome for Arun Gupta. Welcome to
Thank you.
Foxes.
Thank you. I'm excited. I'm excited. Well, we should do a selfie here.
Yeah,
Isn't it?
why not? Yeah,
Yeah.
So at least my wife knows I'm still here, right?
All right.
Cool.
We
Well,
got that.
have fun.
Awesome. Thank you. All right. This is my first time in Bucharest. I'm really excited. So thank you for giving me the opportunity. My name is Arun Gupta, and I work for Amazon for about 2 years now. And I've been working in the open source world for over 15 years now. My first experience really was working at Sun when we took the company from completely closed source, more on the open source side of it. And it's really exciting time to be at Amazon and working in the open source team. I work with a lot of teams across Amazon, helping them define their open source strategy. So today I'm very excited to talk about serverless. How many of you use some sort of serverless today? Very few hands. OK. So hopefully this will give you an idea of what serverless is, what the landscape looks like, why this is relevant. Now, serverless kind of changes the way we build applications, the way we deploy applications, the way we manage applications, or not manage applications, actually. Now, generally, when we talk about serverless, we always talk about functions. Oh, I'm going to deploy a function, and the function is going to run in place, and I don't need to manage it. With the advent of containers, what about containers? How about containers and serverless related to each other? So let's look at that. Is that enough? Is that enough innovation happening at the serverless functions and containers layer, or we need to go down at a layer below and see what innovation is happening over there? So my idea is to kind of give you a landscape of serverless computing. So let's see how the computing paradigm has evolved over several years. We not too long ago, and actually at several places even now, there are people called as server huggers. They hug their server, they have an on-premise data center, they don't want to move, they don't want to touch. You want to provision, you want to ask for a machine. It takes a while, good 8 to 12 weeks to ask for a machine, get a PO approved, get the machine, install the operating system, and then give you a login access. Takes a long time. And that's a capital expenditure that you have to incur anyway. Then we started moving to the cloud. OK, I'm going to take my application, I'm going to lift and shift, move it to the cloud. The VMs are running in the cloud. There are multiple reasons customers move to the cloud. So if you think about it, I generally call them as A, B, C, D, and E. These are the reasons people move to cloud. So first is agility. I can spin up quickly, spin down quickly. Second is the breadth of functionality. If you need like a database, I don't need to run database. I just need a managed service. So give me that service. I need messaging. Whatever I need is up in the cloud. Typically, cost is the factor customers move to cloud. That, I want to cut down my cost. I don't want to have a capital expenditure. I want to have an operational expenditure that is relevant to me. Then you want to be able to deploy to multiple regions across the world. Today, my application is available only in Europe. Then I move to Australia. Then I move to APAC. Then I move to US. You can easily do that. And then last but not the least is elasticity. If you're a server hugger, then you have to plan the capacity in your data center. With cloud, at least there is infinite capacity. Then the third wave of computing that we have seen is around containerization, where customers started building their application. And there are two angles to containerization. One is how it allows you to package your application together with all the dependencies included in it. And the second angle for containerization is the deployment part of it, where it gives you mobility. That I don't care which cloud, which VM it is. I want to run the containers in my data center, or in the cloud, or in a different cloud, and gives me the flexibility on how I can move my application. So that's the containerization part of it. But still, you are responsible for managing those VMs, those operating systems. You need to patch them. You need to upgrade them. You need to make sure your CVEs are fixed. And the fourth, what that we're seeing right now, is around serverless, which is where you don't have to do any of that. Your core competency is to write the business logic. You write the business logic, let somebody else really run that function for you, let the function scale for you. You only pay for the runtime of the function. And that's really sort of what the serverless revolution has been happening for the past couple of years, or a few years now. You basically build code and let somebody else worry about running that code. So let's define what serverless really means. I mean, the way we look at it is there are really four main tenets of serverless. The first one is I don't have to manage the infrastructure. I don't want to provision the infrastructure. I want to bring a function, and I'm going to say run the function, and you run it. And I can do this on EC2 as well if I need to, but then I have to provision the hardware, maintain the hardware, all of that. With serverless, there is no provisioning required, and I'll show you some examples of that. The second part of it is automatic scaling, that today my app becomes popular, it automatically scales for you. There is no auto-scaling group, as we call it, Amazon, that you need to set up. If the application starts becoming popular, it is all of a sudden getting 100,000 concurrent requests, the application automatically scales. And when the number of requests goes down, the application automatically scales down. Because eventually, what you are paying for is that runtime. So that's important to you. So it's very efficient and saves a lot of cost as well. It's also highly available. You don't have to worry about that, where am I deploying my application? Is my application backed up? What if the data center or the cloud data center comes down for whatever geographical disaster? The application is highly available across multiple availability zones in a region. So that way you don't have to worry about that aspect of it. And last but not the least, from a customer perspective, you only pay for the runtime. So yes, you have the function that you have uploaded into the cloud. There is no cost for storing the function in the cloud. The only time you pay is when you are running the function. So these are sort of the four core tenets if you're thinking about serverless. And see how fundamental it is and how significantly different from what we have been thinking so far. Let's look at how we are seeing enterprises across the board. And I'll talk about the history and other details as well. But let's look at it, how we have seen the adoption for serverless in different enterprises. So on the bottom left here is the legacy architecture, and these are running on the on-premise. These are like really big monolithic applications, running fine, nothing wrong with them. But then customers realize that, okay, you know what? We need to lift and shift them in the cloud, because I don't want to run my data center. I'm going to lift and shift in the cloud. So basically take the same application, remove my data center, and now run it in the cloud. So that's one way of it. Then customers eventually want to get to the top right quadrant, because that's the nirvana for them, that I don't want to manage anything. It's a modern application, all that. Then they say, hey, I'm going to look at some of the services. And what I'm showing here are the AWS container services. But this graph is agnostic to the cloud provider. Think of it that way. You can move into any cloud, as a matter of fact, then use their container services to move to the top right quadrant. So you have taken your application, containerized it, and in the cloud, you're getting all the goodness, hopefully. Or you may decide to package it up first, that I'm going to package up my application, and then I'm going to move to the cloud. But the idea being, you're moving into the cloud, you're using containers, and you're able to leverage the benefits. You are able to cut down the impedance mismatch between your different environments and getting all the agility because of that as well. And then there are customers who are skipping all of that. That I don't want to go through any of that. I'm just going to right away jump into serverless domain. I'm going to take my application, and I'm going to straight away jump to serverless. Fannie Mae is a big financial institution in the US, and that's the approach that they took for their financial modeling, for example. So that's a pattern that we have seen. These are very advanced customers, but we have seen that pattern across our customers. So that's the first pattern, and I'm going to show you two more patterns. The organic serverless adoption pattern. This is, again, what we have seen is a lot more common and a lot more prominent in how things are happening. So think about on the x-axis, I have log processing, cron jobs, and stuff like that. This is happening in somewhere in IT. You don't have to hopefully go through a procurement for a IT automation. So you just say, you know what, I'm going to take that, I'm going to take that function, drop it into something AWS Lambda, which is our serverless offering. I'm going to drop it over there, and then the function happens automatically. So I don't need any machines or data centers for that internally. Now, as you are doing more and more of that automation, you start realizing the projects are getting delivered under cost and under budget and under resources. And it's getting delivered faster, because I'm no longer looking at that undifferentiated heavy lifting for managing the infrastructure. I'm just focusing on the business logic here. So that's the time, your CTO kind of starts looking at it. Hey, by the way, this looks like really cool, but instead of just doing simple IT automation tasks, can we look at an application and redesign the entire application to be serverless-centric? So they kind of start designing the entire application. That's where they start looking at it, how rapidly I can deliver the application, what kind of organizational changes I need to make in my company, if at all any, to get onto that bandwagon. And essentially, we see at a very top-level directive that, all right, this department is only going to build serverless application. This is a very common pattern that we have seen amongst a lot of our customers. And the last pattern, called as incremental factoring, or also called as a strangler pattern. Now, strangler pattern, Martin Fowler has written about it. Strangler vines, he found those vines when he was traveling to Australia back in 2004. And these are vines that grow on a fig tree. And they grow from the top, they go down to the root, they get soiled up over there, and over a period of time, they take over the tree, where they become the tree, and the tree is gone. And that's a strangler vine. So that is the pattern that we have seen among a lot of our customers as well, where they take a big monolithic application. From that monolithic application, they carve out one piece of the functionality. They say, I'm going to expose an API to it, and now that's going to be my microservice, and that's running as a serverless function. So they slowly kind of start taking a big monolithic application, start taking out pieces, and then convert a whole lot of microservices and make them talk to each other. So that's called as the incremental refactoring pattern. So those are sort of the three patterns that we have seen across our customers and how and why they're adopting serverless. So let's take a look at how all of this started. My goal is to explain sort of the history and the current status and where we are going with this next. Now, AWS launched Lambda in 2014. We are a very customer-obsessed company. 90 to 95% of our roadmap is driven by customers and feedback from people like you. But 5% times we think about it that, hey, this is what the customers might need, and we create those services. So this is an example of that, for example. Now, AWS is a foundational, the Lambda is a foundational service. That means anytime we launch a new region around the world, Lambda is part of it. Now, just over 4 years ago, we launched it. And today, AWS Lambda really processes, trillions of requests every month. So the scale of Lambda is huge in that sense. So how do I edit and debug my serverless code? I'm a developer. All right, talking done, show me some code. And how do I get this going? And how do I build an application and stuff like that? So let me talk about the tools that you can use for building your Lambda applications. Well, we believe the community is a very key driver for innovation. So what we have done is we have worked with the community to define something called as a serverless application model. Fully open source project. You can take a look at it. It has a fully open Apache 2 specification, which basically says how do you write your serverless application. And in terms of the specification, it's nothing but a template. So in the template, if you think about it, there are 3 key concepts that you need to define. You can define what is your function. You can define what does your table look like. And you can define how do you want to expose the function using API. So you define those 3 concepts, and then AWS generates a representation of that in the AWS cloud for you, and it is up and running for you. Now, this is a link to where the specification is available. A lot of samples are available. But this is what we recommend to our customers if you were to write a serverless application simply. Very easy to get started with this. And I'll show you a live sample. I'm a lazy person, so I want to be more efficient, make it quickly. So I'll show you a sample for that. Now, how do you really debug this application? Specification is good. So we have Cloud9, which is our IDE in the cloud. So you don't need to download anything. It's a service from AWS. You go there, you launch the application. But as a developer, I've never built an affinity to an IDE in the cloud. I need something on my local machine. I'm a NetBeans developer. I'm an IntelliJ developer. I'm an Eclipse developer. So how do I build my applications, these serverless applications using that? So last year, we announced AWS Toolkit for PyCharm, which was GA. So you can build your Python applications and deploy them as serverless over there. And then, of course, we have integration with IntelliJ for AWS Toolkit and Visual Studio Code as well. So look at the different languages that are listed over there. There are a lot more that I'll talk about. But essentially, you can take any of these languages, build your serverless application, and deploy them very easily. Okay? Let's look at some code here. So I have IntelliJ here, and in this IntelliJ, I'm using 2018 3.5, and I have installed the AWS Toolkit plugin. So I'm going to click on Create New Project here, and I'm just saying, create a AWS serverless application for me. So I click here, and I can say, hello, Bucharest, okay? And I'm choosing the runtime here, Java 8, and I'm using 1.8 here, and this is my workspace directory, and that's it. Just specify the name and finish it. And what it's going to do is it's going to generate a template function for me. By a single click, I generated the project, I generated the SAM template that I was talking about, and then with a few more clicks, I can actually now deploy this function into the cloud. Now, one of the cool things about SAM that our customers like it is, you don't have to have a connectivity to the cloud all the time. SAM also comes with something called as SAM local, which is a CLI. And once you download the CLI, you can actually debug your function locally on your machine. And the way that works is this. A partner of ours has written a Docker runtime, Docker image, which basically mimics the Lambda runtime on your local desktop. So you can actually run your function locally on your machine. So let's take a look at that. Now here is my project. Okay. So this is my POM XML. If I look at main here, there are two files. First of all, this is app.java. And in here, I have this request handler is the method that you need to implement, if you are implementing a function. So then you implement this method here. And then in the response, basically you start preparing response now. All you're saying is just prepare a response which will say hello world and return the response back, okay? Now, one thing I need to do is I can go here to Maven, and I can add this as a Maven project. So if I go to say hello Bucharest, go to hello world function, pick the POM XML, and now this project is actually added as a Maven project. And the advantage of that is now there's a Lambda function here. I can click on this Lambda function, and I can say, I can either run the function locally. So if I do this, now it's going to run my function locally, which is using the SAM local API. And I know so when you're invoking the function, you need to send the body to it, some sort of a payload. And at this point, I have nothing to send. So I'll just put empty parentheses here. And this is running locally. So I say run. So this is going to run my function, and it's going to show me the results in a terminal window here. So here you go. So now it's invoking the function here. So if I were to walk you here, it's basically getting the Lambda runtime. And this Lambda runtime being a Docker image, you can just download it once, and then you can continue testing your functions locally on your machine. And then it says, all right, I got the hello world response back. So that's really simple and cool. Now, if I were to create a Lambda function and really upload it to the cloud, then once again, I can say, go here, create new AWS Lambda. I can give it a name, say, hello Bucharest. And I can say, hello. It automatically chooses the handler and the runtime for me. This is Java, so we've got to give it a little bit more memory. Pick a runtime here. I'm going to pick a basic security role and the S3 bucket where this is going to be uploaded, and that's it. So now it's packaging up my function and is uploading it into the AWS cloud, and then I can easily invoke it. And an API is already configured, and if I actually go to my console here, so see here, these are the functions from previous runs. So now if I refresh it, for example, here you go. Here's my hello Bucharest function here, okay? So if I were to test it, I can click on test here. And once again, I don't need to specify any payload here. So I'm going to give this payload a name. And I'm going to create the payload. And now I'm going to test it. So it's going to return the response back to me. So literally, in a matter of few minutes, You have a simple hello world sample up and running for you, and all the plumbing is done for you. So you can just kind of start figuring out that what is it that I need to do? Where does my function logic need to go? And you know exactly the place and start tinkering with it. One of the functions, is when you create the Lambda functions, particularly in the Java land. Let's say you are using Spring Boot as your application. Now, Spring Boot, every Spring Boot application has a lot of jars in there. Now, if you're uploading multiple functions, does that mean each function needs to have all of those Spring Boot jars in there? That's going to take the upload, the download, all of that process a bit bulky. So we introduced this concept of Lambda layers last year. Now, in this case, your business logic is the key. The library A and B, if they're shared across different Lambda functions, they don't need to be uploaded multiple times. So all you can do is you can upload library A and library B as layers. It's a new concept we introduced. You mark them as layers, and now your business function can just rely upon those layers. So you're really minimizing the function size that needs to be uploaded. So it really makes your code a lot more efficient. The loading, the scaling, all of that is really, really efficient. People often ask about the kind of languages that are supported. There are some languages that are supported out of the box on Lambda, for example, Node, Python, Java, Ruby, .NET, Go, PowerShell. These languages are natively supported. And because of the way these languages are built, we extended the support. We enabled of the Lambda layer support. Because of that layer, you can bring your own language runtime. And that's how we added support for C++ and Rust runtime. And take it or not, people actually build support for COBOL. I've seen Fortran runtimes running in Lambda. So pick a language of your choice, and the C++ and the Rust runtime are open sourced, so you can take a look at them, how these runtimes are made. Feel free to make your own runtime. So there's COBOL, Elixir, PHP, all sorts of runtimes that are available. Now, one question we should ask is, that's sort of the traditional way, and I talked primarily about Lambda, but Google has a similar offering. Microsoft has a similar offering. Microsoft has Azure Functions. Google has Google Cloud Functions. The level of support, the language support is a bit varied and a bit different. So definitely recommend when you are looking to pick, where should I deploy my serverless function, take a look at it. What is it that you want? Don't look at it as a golden hammer. Never do that. Now, how can the serverless benefits be applied to other services? Something that we launched a couple of years ago, which went GA last year, is Amazon Aurora Serverless. Amazon Aurora is a database service that we have at Amazon. And this is very well suited, particularly for if you have a bursty loads, where you send a request, you do some database calculation, and then for rest of the day, or rest of the evening, or rest of the week, nothing is going to happen. So that kind of a bursty load, Amazon Aurora Serverless is perfect. Because what you're doing is you're really paying for your database connectivity, and the database rather starts up quickly and shuts down quickly. So again, truly applying that serverless methodology, pay for what you use, no infrastructure to provision, pre-provision for you, that about that. So that's cool. Now, what about containers? How many of you write applications using containers? Some sort of containers. Quite a bit of you, so about 30% of the room. Now, how do I apply this concept? As we talked about, containers really allow us to package our applications easily and move them around to whatever computing environment you want to do that. Desktop, cloud, on-prem, whatever cloud, gives you that mobility, and that's really helpful. Now, let's think about it from a higher level perspective. If you were to deploy a container application, you basically need two things for a container to be running. Well, first of all, you need what you call as a control plane. And then you need a data plane. So data plane is at the bottom, which is where your containers are running. Okay? That's where your EC2 instances are running, hopefully a cluster of those. You don't want a single point of failure. And on that cluster is where your instances are running. So once those instances are running, then you need a control plane, which is what is going to manage your data plane. That, oh, I got 8 nodes in the data plane. I want to make sure the 8 nodes stay up. You're asking me to schedule a container I need to make sure that the container is scheduled at the right host. It meets the memory and the CPU requirements. Things like those are very important. Controller. You want me to make sure that the container stays up. I'm the controller, container controller. I'll make sure the container stays up. If it goes down, I'll bring it back up. So you need different components in the control plane. Now, a service that we introduced a couple of years ago is called as AWS Fargate. So just like Lambda made it possible to run your functions without managing infrastructure, AWS Fargate is a service that we introduced that allows you to provision containers without managing any of that infrastructure. You don't need to worry about, what is your control plane, what is your data plane, I don't want to manage the server. We have a lot of container services as well, but you don't need to worry about any of that. And again, one of the cool things that we like about Fargate is how just a year after general availability, customers are launching tens of millions of containers using Fargate on AWS Cloud. And another option that you can look at it is Azure Container Instance, which is again very similar to Fargate, but essentially you bring your container to them and then they run it, and you don't have to manage and provision the infrastructure for them. So when you run your Lambda function, in your Lambda function you specify, here is a CPU and here is a memory that I want to provide. So this is very similar to that in that case. So when you are running your Fargate containers, you're saying, here's a CPU that I want, here's a memory value that I want. So you have a single knob or single dial for your function. That's all I care about. And then the CPU and memory you specify, but the network is automatically allocated for you. So sometimes you may realize that I want to allocate more memory because I want maybe more network capacity. But these are the only two knobs that our customers are given. And so overall, it gives you about 40 combinations. Now, let's go back to the diagram that we were looking at earlier. Yeah, of course, you have a control plane, you have a data plane. Now, in terms of control plane, Amazon offers a couple of services, which is Elastic Container Service and the Managed Kubernetes Service. And on the bottom side, of course, there's a data plane. But think about the complexity of running a data plane. You need operating system, you need Docker to manage the Docker containers. You need some sort of an agent, a kubelet in case of Kubernetes. There's an ECS agent in case of ECS. So it's a very complicated scenario. How does Fargate solve it? You don't need a data plane. There is a data plane, but you don't need to know about it. You just bring your containers, you talk to the control plane, and the control plane runs it. So I think that makes it really, really beneficial. This is where the customers feel that they were doing undifferentiated heavy lifting to bring the EC2 instances, manage those instances, patch those. None of that is required now. Very simple. You just bring your container. Literally with the AWS CLI, you can provision it. And if you go back to what we were talking earlier, this is very similar to how Lambda is run as well. So you have a control plane and you have a data plane. You don't know what the data plane looks like. You don't know what kind of EC2 instances are being used. You give me one knob, CPU, memory, and I provision your Lambda functions in the backend and run it for you automatically. Now, one of the customers for Lambda is FINRA, which is a financial regulatory authority, which is a nonprofit in US. And just to give you the scale of FINRA is, FINRA has about 99% of equities go through them on a given day in US, all of US, okay? And about 65% of options trades go through them. And so what FINRA does is it does validations that anytime any trade, imagine real time, anytime any trade is being done in the US, FINRA does a real-time validation of that trade. And if they have about 200 plus rules, if anything goes wrong, they can immediately signal the feds to shut down the market. Imagine US market could come down. FINRA is running using AWS Lambda, and they do about 500 billion, 500 billion validations every day using AWS Lambda. What was the biggest advantage to them? Earlier, they had a system built on AWS, but they were taking about average of 3 minutes and about average of 7 minutes in the peak time to run those rules. But with AWS Lambda, it gives them infinite capacity and a constant 1 minute of response time. So it's a huge response. There is no scaling requirement, there is no provisioning requirement. They can focus on their app. That's the biggest benefit of serverless that you want to think about. So in general, the way we look at it is, if you were to look at At Amazon, we have this concept of a shared responsibility that we always own the data center and the physical security of it, but customers own part of it. If they were to build their application, so depending upon how you are looking at it, EC2 or container service or Fargate or Lambda, there's different roles and responsibilities that you can play. But as you can see, if you're going to the Lambda side of it, really the only thing that you need to focus on is in your application. And that's the joy of it. I don't want to focus on all that managing their infrastructure. Let's look at a broader landscape. Now, Lambda was launched many years ago, and AWS definitely has benefited from it. But a lot of our customers and partners have benefited from it. So Cloud Native Computing Foundation is a third-party foundation where some of the most prominent projects on GitHub are hosted. Kubernetes, Prometheus, Envoy, those projects are hosted over there. There's a working group in CNCF where they talk about the serverless landscape. So first thing to understand is they produced a serverless white paper, which talks about what serverless is, very similar to the tenets that I talked about, which talks about where it should be utilized, how it should be consumed, and all that stuff. So that's the important part. Now, this is called as a serverless landscape at CNCF. And in that, basically, they talk about what are the tools, what are the platforms, what are the frameworks that are available around it. So some things that I want to particularly highlight over here is serverless.com. Serverless.com is run by a small company based out of San Francisco, but they have about 28,000 plus stars. I literally checked it yesterday. They have 28,000 plus stars on GitHub, so hugely popular. And they've done a fantastic work. So as much as AWS Lambda is only AWS, serverless.com really allows you to build your application and deploy it to any cloud very easily. And a lot wider variety of languages that are supported there as well. So that's definitely worth something looking into. The other things that I want to highlight here is there have been a lot of frameworks that are available. Kubernetes is getting a lot of mind share. A lot of customers are looking at Kubernetes as an offering to run their infrastructure for containers. So a lot of frameworks have come up, things like OpenFaaS that can run on top of Kubernetes, but then they give you function as a service offering. So yeah, you already have an existing Kubernetes infrastructure. You want to run a function on it. You give me the function as a container, and I will manage that. But I think the way we look at it is it's a very narrow part of serverless, and I'll explain that in a second. Because serverless is a lot about how many events can trigger your function. Because that's an important part of it. If the function cannot sit in the isolation or in a silo somewhere. So I think you definitely want to look at some of those. The other initiative that I also want to talk about is Knative. Knative, again, is an open source project, not part of CNCF, but Knative runs on top of Kubernetes. Well, Knative runs on top of Istio, which runs on top of Kubernetes. It's pretty bleeding edge stuff, evolving very rapidly. But I think one of the things that I see with all of these frameworks is the fact that you are running Kubernetes at the back end, there is an infrastructure running. So there is a cost that you are paying. So we don't feel that that is true serverless. Because for serverless, from a customer perspective, you should not be paying a single penny when your function is not running. So let's take a look at it. We talked about Lambda function cannot sit in isolation. So in this case, what I'm showing you here is how there are different services that generate events. Something is stored in the queuing service, or there is a notification from the SNS, or some object is stored in S3, or somebody committed a change. So what you can do is those are different actions that are generated from different services at AWS, and Lambda can really be the glue to that. You can say, that happens, trigger a Lambda function. And that's a very common design pattern that we see across our customers. One of the examples is John Deere. John Deere is a customer. They build tractors and harvesters. So from their tractor and harvesters around the world, which are IoT connected, they generate an event. It goes to Kinesis, which is our streaming service. Then as soon as the event goes to Kinesis, Lambda kicks in, does some functional processing over there. Then it sends it to our managed database service. Again, Lambda function kicks in, and then it gives it to the end user. So there's a linear processing that can happen, that can be easily connected using this. So this is cool, but this is only across within AWS. And if you look at other vendors, Google, Microsoft, whatever they are, but they have similar services as well. The range of events that they can offer could be different, but similar services are there. So there is storage, database management, and they can all trigger their corresponding functions. We feel that majority of CIOs pick up a single cloud because digital transformation is a hard task, and then managing multiple clouds is all the more hard because you lose the value. But there are cases where you want to store something on, say, some other cloud's storage service, but want to trigger a Lambda function. Or you want to store something on S3 and want to trigger a Lambda function equivalent on a different cloud. How does that work? So how does that model work? So for that, the serverless working group at CNCF has been looking at cloud events. And what cloud events is doing is defining a specification that how should the event data look in terms of across different cloud providers. It defines common formats to provide interoperability across services, platforms, and systems. As you can see, there are lots of different specifications that they provided. And by the version number, you can also see is 0.2. So still very early days. But if this is something that matters to you, if this is something you care about, highly encourage you to participate in this effort, cloudevents.io. It's a very open call. You can just join the call. It's a Zoom call. Very useful. So that's cool. That's cool about the application side of it. What else can we do in serverless computing? What about the infrastructure? So today, customers, when they're deploying their functions, so if you think about containers, for good or for worse, they don't contain. You can't run 2 containers from 2 banks on the same piece of hardware. They're not meant to run in a hostile environment. And this is primarily from the cloud provider perspective. So let's see what can we do in the infrastructure side of it. Last year, we introduced a brand new open source project called as Firecracker. Firecracker is basically an open source virtualization technology. It's basically a virtualization machine manager, or VMM. And it really gives you, you generally would not hear security and fast boot up time together in a sentence when you're talking about containers and Lambda. But what micro VMs, Firecracker allows you to create a micro VM based upon KVM, which is a standard virtual machine manager. And it says they give you enhanced security, and they also gives you the speed and density of containers. So up until now, we were relying upon that, OK, here's a Lambda function coming from you. Here's a Lambda function coming from you. We're going to run them on 2 separate EC2 instances because we want to make sure there is security's top job at AWS. We want to make sure these 2 don't collide with each other. So we're giving you that security. But if you think about it from the cloud provider perspective, that's a lot of wastage. Because what if you run the function once and then you don't run it again? Or what if you don't scale it? What if the EC2 instance that we provision has a lot more capacity and it can learn a lot more? So in that sense, it became hard for us. So now, Firecracker was really built at Amazon, and it's purely as an open source project, which is the secret sauce on how we provision our Lambda functions, and also AWS Fargate. And these micro VMs, they're designed to start fast and quickly. Now, Firecracker micro VMs provide KVM-based virtualization that provides enhanced security over traditional VMs. So it gives you security from the ground up because the Firecracker micro VM has, by the way, one of the things that you may like to know, Firecracker, how many of you know, what is the nearest Amazon development center for you guys? Which is the closest one? Shout out somebody. How many of you know there is an engineering center in Bucharest here? There you go. So I would like to call out, actually, there is an engineering center. So this particular project, Firecracker, was built here, right here. And I was there this morning. I had lunch with the Firecracker team. I've been working with them for several months now. But Firecracker was built here. These guys were planning to be here, in the evening, but unfortunately, they cannot make it. But if you guys are interested in getting connected to the local Amazon team here in Bucharest, not Iași, that's a long way from here. You live in Bucharest, you want to work here. Interesting personal story. During my interview, Amazon says, would you move to Seattle? I said, but I live in Bay Area. So I won't move to Seattle to work for Amazon. I live in Bay Area and I work from there. So I completely understand. You live in Bucharest, you want to work for, if you want to work for Amazon, if you want to know more about it, by all means, my DMs are open. Shoot me a message, and I'll be happy to connect you with the local engineering team here. Back to the project here. So Firecracker gives you a minimal device model. It has a vert.io block. It is a single-digit keyboard. And that single-digit keyboard is basically used to boot the VM or shut down the VM. So it moves really fast over here. So it really gives you security from the ground up. It also gives you speed by design. You can launch the micro VM. We're not talking about seconds here. We're talking about 125 milliseconds. You can boot up a micro VM in 125 milliseconds, and that gives you the ability to bring up about 150 micro VMs per second per host. That's very relevant from the perspective that, hey, you know what? I ask my Lambda function to run. You run fast, and you run secure, and you run quick. And that's the technology that is powering the AWS Lambda backend. And the other part of it is the scale and the efficiency. The memory footprint of micro VM is really, really tiny, and that gives you the ability to run thousands of micro VMs. The way micro VMs run is on a bare metal instance. So I played with this on a bare metal instance, or you can run this on a nested virtualization. So for example, I think the week after Firecracker was announced at reInvent last year, Joe Beda, who is Kubernetes founder and now works from VMware, he talked about how this could run on a nested virtualization, essentially on a Google Cloud. So it's truly, it's not an AWS thing. It's an open source project, and we are working with container orchestrators, how they can leverage this technology to bring serverless computing to the next level. Now, the important part to understand is Firecracker is very much a foundational technology. Okay, it's not something. Yes, you go to AWS Cloud, you say, okay, go ahead, provision my EC2 instance, and it'll provision an EC2 instance for you, and you can deploy your code over there. But Firecracker Micro VM is not in that concept. It's a much more foundational technology. As I said, it's used as the backbone for Lambda and Fargate. Kata containers was an effort that was started about 2.5 years ago, and Kata containers were doing a similar effort. And this was really started by Intel, then it contributed to OpenStack, and that's where the project lives now. Right after the announcement, Kata containers got very excited. Now, Kata containers use QEMU, which is again a VMM layer, for the virtualization aspect of it. But QEMU allows pluggable hypervisor, or actually, Kata containers allow pluggable hypervisor. So they worked with the Firecracker team to allow Firecracker to be used as a VMM for Kata containers. And Containerd is how a lot of Kubernetes clusters are run to provision the containers. So we have a project out in the open source again, which talks about Firecracker and Containerd integration. So essentially, the way we are looking at it is, all across the board, the different efforts that are happening, how can we up the level of serverless computing and make it really easy for everybody to adapt? So why does it all matter? And this is the big deal. So by the way, for those who don't know, this is Werner Vogels at reInvent a couple of years ago. So why it matters? It matters because end of the day, I don't, as a developer, not as AWS, but as a developer, I don't want to provision server. As a developer, I don't want to manage my server. I don't want to be worried about my CVEs, patches, security, what operating system version. I don't want to be worried about, am I using cloud best practices? No, none of that. I want to look about lower cost. I want to worry about time to market. Those are the factors that matter to me more than that what version of the server I'm running. So this is exactly our mantra, that essentially you should be able to focus exclusively on the business logic and let everybody else be handled by the serverless computing. So as a developer, I love to build applications, and that's my recommendation to you. Go build the application and let us know how we can help. Thank you.
Okay. Great. Thank you, Arun. So we still got a few minutes. Any questions for Arun while he's here? Just raise and, yeah.
Hey, Arun. Several years ago, they said, Lambda, it's the death of DevOps. Do you, not you, but, well, somebody said that. Do you still share this view? That's my first question. The second one, if not, then what's the specific use cases this Lambda addresses?
Yeah, well, the question is Lambda the death of DevOps? I don't think so. I mean, I think the functionality and the roles appear and move to a different side of the world. Um, think about what DevOps is. If you think about DevOps from a higher level, it's about automating your processes, making it simple, and moving it a lot more efficient, essentially, right? Now, in case of Lambda functions as well, sure, writing one Lambda function, uploading it to AWS cloud works very well. But typically, if you look at your application has 500 microservices, right? Or 100 microservices. Now, how do those microservices need to collaborate with each other? How do you make sure that you're following a design pattern when you upload those microservices one by one, they're able to scale up and down? So I think the point being, you are only taking part of the role away where you're not managing the infrastructure and all of that, but everything around application, you still have to follow the design pattern. You still have to kind of coordinate those responses. It's only giving you a tool to fundamentally build your applications using the right design patterns.
Any other questions?
Over there.
That's it.
Hi, so Amazon is lately investing in ARM-based processor implementations. How does this relate to what you presented, especially to the Java world, in terms of pricing and performance and compatibility?
Yeah, so we recently made a general availability of Corretto, and Corretto is open JDK distribution. So at this point of time, Corretto, for example, is available on a variety of platforms, so Mac, Windows, all sorts of Linux platforms is available over there. And we also have an ARM experimental build. The other part to understand is James Gosling, he works for Amazon, and he constantly harasses us that, I want an ARM build as soon as possible. So that's constantly on our head, he's hitting with a hammer that I want an ARM build, I want to move to Corretto. And because he apparently runs a bunch of Raspberry Pis on his desktop, and he's using some random build of Java over there, but he wants to use Corretto over there. So that's one thing. The second part of it is, when you go to AWS console, you can provision an EC2 instance. And there you can say, I want to run Linux on usual AMD processor, Intel processor, or I want to use it on ARM processor. So all of that is available, and the pricing is all listed on the website. So the performance you have to kind of evaluate yourself. Performance could be very varied from the customer perspective, and it really depends a lot upon your application as well.
Arun, question here.
Hello.
Hi.
So what do you think is the main stopper for using just AWS Lambdas? And maybe some services, predefined services, but let's say I have a new business and I want to run everything on AWS Lambda.
Yeah, thank you. We have a lot of customers. We have hundreds and thousands of customers all around the world, anywhere from a startup to a top-level enterprise. A lot of startups, they start on AWS, and then they continue to grow on AWS. Lyft, Netflix, Uber, Airbnb, Slack. These are all in AWS customer. They only use AWS. So there are a lot of customers like that. But to your question, I think a lot of the times customers look at it that, am I ready to move to the cloud? And they need a lot more guidance in terms of, how do I lift it? Is the question right?
So let's say I don't want to have my own server developed like, I don't know, Spring Boot or whatever, and I just want to use pure Lambdas.
Yeah, that's totally possible today. That's totally possible. I think the blocking factor might be is some people think that, if I'm going to Lambda, that's only one cloud. I want to have a little bit of more independence. How do I do this locally on my machine? And that's where we are looking at things like SAM local. So when I was showing you the IntelliJ, I did not connect to the cloud. I was testing my app locally. But what that means is only your app is running locally. But if your database is in the cloud, it's going to go still talk to them. So there are definitely things for us to do in terms of improving the local development experience. But that's one of the things we have heard from the customers.
Okay, last question. So I've got a question for you, actually, all. Who is using Amazon AWS? Okay, and who's using Google Cloud? Okay, and Microsoft Cloud? Okay, and just for fun, Oracle Cloud?
What? They have a cloud?
Well, Arun, thank you very much.
Thank you.
So that's the end for the day. So have a great evening, and tomorrow morning, 9:30, we'll start with the opening keynote by Mark Heckler. So see you all tomorrow.